Hello everyone, welcome back to my channel where we are learning blockchain. As we are going towards the blockchain learning journey, there is a particular concept of Merkle tree. We have seen this into our blockchain explorer also, that there is a Merkle root which has been provided by all the blocks, right? So we need to understand this concept. Even though Merkle tree is a very major concept from the Bitcoin, but we can still make blockchains without Merkle tree. But in today's world, Bitcoin is vastly using Merkle tree, and you can see this in each and every block which has been created. Let's deep dive much into this Merkle tree. So let's understand the theory of a Merkle tree before getting into a practical session, right? So what is Merkle tree? Merkle tree is simply a representation of a data structure, right? So what it is, you as a word called tree. Tree is like there is a branches. So from transactions to the hashes, each transaction has a hashes, and combining all these three is coming as a tree. And Merkle root is a top of the tree which is giving you a single cryptographic hash value of all the transactions, right? Maybe a little confusing, but I will get into a session just after a couple of seconds so that you will understand that how practically it can be looked like, right? Also, we can call Merkle tree a hash tree because it's a combination of hashes from all the transactions. Let's see this one. If you remember that we have gone into the sites of Blockchain Explorer where we have seen the block. Suppose I am into a block of 823,695. You can see here it is as a Merkle root. So what this Merkle root is giving you a single cryptographic hash for all the transactions of this particular block. So how many transactions we can see in this particular block is 5256. And this Merkle root is a combination or a concatenation of all the transactions for this particular block. And this is a single source of truth that all the transactions have been used, right? And this is also used as a verification and validation for this particular block. So I want to give you a little bit pictorial understanding of this one, but I will not take in examples of 5,000 transactions. I'll rather take a very simple transactions of maybe 4 transactions so that you can understand that how actually it is getting concatenated, right? Suppose I'm taking an example of 4 transactions. Each transaction will have its own hash value. I'm giving this transaction's hash value as 0, 1, 2, 3 for our easy understanding, right? Now what happens? These two hashes are concatenated and giving you a single hash value as hash 0, 1. Similar way, hash 2 and 3 is also concatenated and giving you a value of 23, hash 2, 3. Now what happens? You can see this has become as a tree structure. So what will happen? If we will combine these two hash values also, it will give you a Merkle root. So that will called as 0, 1, 2, 3. This is how the Merkle tree has been defined, and we are using it as a big concept with the concatenation of all the transactions coming it as a Merkle root. I want to give you an explanation into a website also so that you can understand that where actually it is looking, which is similar to the one which I have shown you in my previous slide. Okay, I am into this slide. Let me get into the Explorer and I will just get into any block to just check the Merkle root. Let me just pick a block. I'll pick this block. So block number is 823,857, which I have clicked on. It is just coming up. Okay, so we are here. You can see here total number of transactions on this particular block number has been done is 4,745, right? This is the number of transactions. And we have this Merkle root. This is the cryptographic hash value of these all transactions. So what is coming up? All close to 4,700 transactions have been clubbed and concatenated to a single tree, and that tree has a single root which is used as a cryptographic hash value for this particular block, and this has been used as a verification also. People can understand that this cryptographic hash value has the transactions of this number, right? So, and sometimes if suppose somebody is trying to force this particular block or any transactions, this Merkle root will also get changed because the cryptographic hash value will change. So what will happen? Again, a verification validation has been done for this particular block that somebody has touched something within this particular root, right? So this is the beautification of Merkle root, serves as a positive validation and the cryptographic hash value to understand the number of transactions have been used for this particular block, and it is giving you a mathematical data structure. I hope you understand this one. Please dig deep more. And if you are not understanding, rewind and listen more again and again about this Merkle root, because this is an important concept to be used within Bitcoin. Thank you so much for listening. I'll meet you again in my next session. Thank you.